So, talking metallurgy and making fiber metal, metal of a dying star, metal of the gods, so to speak. You're talking Mjolnir, Stormbreaker, Thunderbolt, armors. You're talking all of these new metals and re-entry panels for ships where there's no more heat shields, so to speak, like classic days. And it's pretty simple. You get a laboratory. You make molds that have what is like acupuncture pins all over them, and they're made out of like a high quality steel. Then inside is the vacancy of the mold. And these acupuncture pins work off of arcing towers, like a Tesla tower. And what it does is the magnetism in the pins and the actual electric current of lightning can flow through them like a grid. Then inside you have the liquid, a cryogenic liquid that's very cold. And all you're doing is pouring in particles. Let's say you want to make layers. So if you want to do aluminum first, you pour in aluminum and you shift the mold and all the aluminum particles settle like dirt at the bottom of a lake. Then you use all of these little pieces, these little acupuncture-like pins, and they arc off intelligently a Tesla tower. And now you have ice-cold cryogenic liquid that's approaching 0 Kelvin, and that's your cold quench. And then you have all of these particles that are sitting on one side. And what you're going to do is you're going to arc lightning through them. Now, it's creating what is the close environment of right after everything blows away from a star, except for what's left as a neutron star that just didn't have the oomph to become a black hole. But what it does create is a massive blob of liquid metallic elements that then cool down to 0 Kelvin as quickly as they possibly can while fighting the core of what's left of that star. So now you have, let's say, one layer that you're building up microns at a time using these particles and you want pure aluminum on the inside edge for flexibility. Then a layer of carbon, and you could even do carbon as a control for the actual density and weight of the panel. And now aluminum can weld to steel. It's made in stars, and dying stars can do this. So we flip back. And we go, holy shit, Native Americans and, well, indigenous, if you want to be PC, and all of these other people that talked about these Vimana, these crafts made out of metal that like look shiny like gold, but it could fly into space and come through the atmosphere. Well, we're talking about metal of a dying star. So now you have the mold there. You have, let's say, 5 microns of pure aluminum, or let's say we want to do 2 mil. So 2 mil. And as the particles are pouring in, we stop pouring particles into the cryogenic liquid in the mold every once in a while, and we shock it. And we try to weld everything using this vein of electricity through all these little acupuncture pins. Then that density is going to become like a star. It's going to make a panel on one side and leave rest of the room for the mold on the inside. And then we want to do the next layer, let's say high carbon steel. And we're talking new armored steel, welded to the aluminum, but we want it to be light, like aluminum. So we take carbon particles, we mix them up until they're evenly distributed, and then we pour that into the mold, and we allow it to settle over the aluminum. Then we arc in through the pins again. And we do this process until we have 2 mil of aluminum, 2 mil of high carbon steel with carbon weight reduction, and it also gives us the ability to make it where it's like a carbon fibric metal. So that's why I call it fiber metals, because it's like magma. It's like it creates fibers as it cools down, almost like quartz. So now what we're doing is we're quenching, and we're quenching, and we're quenching. And we have to off gas because it's going to get so hot from the electricity flowing through those particles that hot versus ultra cold is going to cause the distribution function of a high pressure system. So now we're off gassing whatever we can and replenishing the cryogenic liquid and pouring the next layer down inside of metal until we can make 5 different sheets where it's aluminum, high carbon, Then we could do technically stainless steel, so there's rustless components. Then high carbon. Then the outer panel, we want to have super conductivity, let's say. We could do gold particles in there if you wanted to make the outer panel super conductive, even though that's going to take away from its heat ability. You could always throw another panel on top that is your heat shield. So now you're talking about putting the actual wiring system directly into the metal panels. And this mold, after you use this mold, which can withstand the arcing and the cold, and then at the end, the CNC bit just has to be made out of a harder material than what we're creating. So it just has to be in its own mold, created with a higher heat to quench ratio, with stronger metal components, and even potentially diamond particles. And now we can take even diamond particles and we can make diamond-laced stainless steel. We can make stainless steel that doesn't melt until over 8,000 degrees. We can do even diamond particles in it that make it extremely resistant to cracking, extremely strong. And now that's in the metal. So we can do this, and we can make another sheet on top that's for reentry. Let's say diamond and steel, higher quench steel. So now we're doing this product. So we make 5 layers, then we make another sheet in another mold, and then we're taking a CNC bit, and we're just taking away the mold. The CNC bit just takes away the steel, because it's going to be welded to create smoothness to the steel mold. Now, when we have the steel mold and we CNC away everything else, what we're left with is these panels, the panels that we need for a spaceship. So even if we have triangular truss aluminum framing throughout the whole spaceship inside, and that saves weight, we can now make these component panels that can withstand way higher temperatures. So you're talking about jet engines and impellers and cases that can withstand over 8,000 degrees, meaning you can put lasers in the aft end, and using the jet, you can now get to space. We can make those cool jets to go to space. Going to the moon is pretty simple. A small tank that goes with the ship that just has enough oxygen to burn off like a rocket, in essence, using the laser in the aft end of the jet casing to create heat, where it creates just a heated sphere that hits all the lasers, reflect back into the sphere, and make it hot. And now that won't melt, and we can contain the temperature. And now we're talking about jet engine-like jets. And this just comes from metal from a dying star. So if you want to learn, go learn about Mjolnir, Stormbreaker, Thunderbolt, all these ideas that we see in movies. How would the metal work? How would the density of the metal function? And we often find that in the stories of what seems like fantasy is the answers to the questions we're asking ourselves in real life. Can a hammer fly? Yes. We can technically make a hammer fly. Now, you're talking about then that you can sound like a crazy person, but the fiber metal comes from a dying star, because that includes the density. So to recreate nature, which is that neutron star, that dying star metal, we're talking about there's only very few ways to do it. Extremely hot, but we'd have to put it up against the sun, basically, and then put it into deep space. Or we can use cryogenics and not have to freeze ourselves anymore, but we're talking about quenching metals with cryogenics and off-releasing whatever we need to, including losing some of that liquid from inside the actual mold, which we can then replenish with more cryogenic liquids. So the easiest way to put this is that if we get scientists on this, we're talking about having jets that fly to space, can fly to the moon, can fly up parts for a space hotel and casino, thrusters. And in another video, I'll make a video about arc thrusters. But I figured out the secret of arc thrusters because I learned how to create fiber metal. Now, I would love to be in the laboratory, and I'm hoping that someone sees this and sees what's going on in my head and understands that I may not have the most technical degrees in science knowledge, but I do have a passion, and I will speak my heart out in front of scientists to get this to become a reality. We're talking about we're no longer flying in rockets, and then that's the start to the actual future that leads into we hone in these metals and jets that fly to space and the moon and Mars. Now we're accessing Mars using jet engines that just has a tank of fuel, mixed air basically. It doesn't even have to be pure oxygen. It could be much less dangerous on the bottom of the ship. And then we can use that to fly in space and even take back off of Mars, because Mars we can use jet engines. There's an atmosphere. So we're talking about the ability to actually recreate ships from old models that have the ability to not use rocket engines because the metals can withstand the temperature even inside the casings, which then we can squeeze with the crab claw clamp on the back end of the jet casing, and we can make this jet go extremely fast. We can use these hardened metal valves underneath to move air in our atmosphere and to give us that drunken pirate ship look, so to speak, of, let's say, the Guardians of the Galaxy ship. In my head, I see how to build that ship and eventually in the future bring it into the warp world. So, sorry about the burp, excuse me, I mean. And I'm ready to put my passion to work. So I hope you guys enjoy this video, and it's just a way of making